All right, so we move ahead from our previous slide or previous lecture here. So we can see right here, uh, we have this figure of electromagnetic spectrum right here, as you can see. And what we see here is that in this figure, we start with the long waves. So on the left side, this is the frequency, and on the right side we have this wavelength. So as I have explained you, wavelength and frequency, they are inversely proportional to each other. So frequency up, wavelength lambda down. So start with the long waves, which has a frequency range about 1 megahertz. So uh, you see that the wavelength for that kind of electromagnetic waves is about 1,000 meter. So 1 kilometers, they are so long wave. And if we go up, we come to the section of radio waves, which are used for television signal propagation. So they have frequency ranging up to 10 megahertz to 1 gigahertz. And in that category, you have three types of waveforms. One is ultra high frequency, very high frequency, and very high frequency. So based on this frequency range classification, this VHF is used for FM, that is the radio that we listen, and the signal that we listen from our radios, various stations, and they use this very high frequency, which ranges from 50 megahertz to 100 megahertz. Okay, so specifically is about 2 to 6 megahertz. This is 7 to 13 megahertz. That's a very specific frequency range. So what about if this is the frequency range, then what is the wavelength range? Wavelength of the radio waves, which are used for TV or the FM, it's about 1 meter to 10 meter in the size. So next is your microwaves. So in that you have a radar which has a wavelength of 1 centimeter to 10 centimeter, and the frequency range is about 10 giga to 100 giga and so on. Then comes your thermal infrared section, which has a thermal infrared and the far infrared. So thermal infrared, as I explained in previous slide, so it has a wavelength about 100 micrometer to 1 millimeter. So you can see that, and the frequency is in now uh, 10 to the power 12 to 10 to the power 13. So you see that we are going up in the frequency and we are going down with the wavelength. So this type of waveform. Next comes after infrared, there is a spectrum called as visible. So this is a visible electromagnetic wave. So they are quite near IR. They are also called as near IR waveforms, electromagnetic wave, because you see just below it is your infrared. So now this visible spectrum has long range of other electromagnetic visible waveforms. So you see the blue light, they have a wavelength about 400 nanometer. You have a green light about 500 nanometer, and up to orange 600 nanometer, and the red is about 700 nanometer. And the frequencies about that would be 10 to the power 15 to 10 to the power 14. So you see now this is the frequency range. We go up in the high frequency after visible light. We come to the ultraviolet. So the frequency is going from 10 to the power 16 to 10 to the power 17. And the wavelength goes from, let's say, 1 nanometer to 100 nanometer. So if we go up in the frequency, the wavelength goes down. Okay. Finally, we have X-rays and the gamma rays. We have seen that before. So again, the frequency is extremely high, 10 to the power 19. And you have the wavelength 0.1 nanometer to 1 angstrom. Okay, so remember 1 angstrom is 0.1 nanometer. So here it is this how. So we have understood in this slide, what is an electromagnetic spectrum again, refer to the previous slide also. So it contains the broad range of wavelengths, or you can say broad range of frequencies. There are different types of waves, and each type of wave has specific wavelength and the frequency. So hope this is useful, and we stop here.